Happy third talk at Developer Day. I'm Neil from the Dev Relations team. My team advocates on behalf of all kinds of developers, not just marketplace vendors, but in-house enterprise developers as well. I'm excited to have Stefan. I'm sorry. Sebastian. I was going to say the name of another speaker. Sebastian Hess from K15T. Guys familiar with K15T? So you started working there about 4 years ago. I think you worked on the popular tool. Which one was that?
The Scroll products.
So. Yeah, the Scroll products for Confluence, and now you're working on Backbone Issue Sync, which keeps issues sync between a bunch of Jira instances.
Correct.
Yes.
Yeah.
Awesome. Well, welcome, and please welcome Sebastian.
Cool. Yeah, thanks a lot. Going serverless. This is easier said than done, and we have done it before. So today, I want to give you some tips and tricks for developing a serverless cloud app so that you can learn from our experience. My name is Sebastian, and yeah, as Neil mentioned, I'm from K15T, a top vendor and platinum solution partner from Germany. I'm working on Backbone Issue Sync, and we are the guys to keep your issue data in sync between different Jira instances. So that means if you connect to Jira projects and you want to work on the same data but in different instances, we synchronize the changeover between the projects. And we have brought this product to the cloud some while ago. And we're using serverless functions to synchronize any change between the two Jira projects. Before I start to share with you the best practices, just a quick recap about what serverless actually is. So before we started to adopt the serverless functions, we had some requirements to it. We wanted to receive webhooks in order to provide some kind of real-time synchronization or almost real-time synchronization. And we had also the requirement to have some tasks which are running a bit longer, so we needed to support that as well. And we also wanted to support some scheduled tasks, so that means we want to run some tasks on a maybe daily or weekly basis. And I think these use cases or requirements are fitting quite good to the serverless functions. And let me explain why I think so. In a typical cloud architecture, you usually have some kind of virtual machine or maybe some Docker containers in a Kubernetes cluster. You might have your database running on, maybe you manage this by yourself on on a separate system. So this is nowadays kind of the state of the art, have some microservices. But the difference here for your serverless functions is that you split up your app in a lot more single-purpose functions. And then those functions, they build your app. And since the functions don't run all the time, you need to store your data somewhere. Oh, wait, I missed a transition. So you need to store your data somewhere. This could be like an S3 bucket or a DynamoDB. And now the big difference here is that since your functions do not run all the time, you also don't have to pay for them, compared to your typical cloud architecture, where at least one instance is running all the time because you never know if someone is making, for example, a request to your app. And this was now especially interesting in our case because we only wanted to pay for the actual synchronization between the data. So our functions are then only running as soon as a change happens and we synchronize it to the other side. As you might have seen now, we are using AWS for that. So we are using AWS Lambda, which is probably the most popular serverless service. But we are also using other services besides that from the AWS ecosystem. To quickly give you an overview how this then works, so you usually have your code artifact, which you use as your Lambda function. And this code artifact could be a jar file or a Node.js script or whatever. And you upload this to the Lambda function or to the Lambda service, and it will be invoked. And such a function could, for example, look like this. So this is a really simple example, which I use quite often in my talks about it, but it gives you a good impression how this looks like. So you receive an event in your function, which contains some information. For example, if it's an HTTP request, you get some information about the HTTP request data. You have some context parameter where you can get some context information about your function, and you have a callback function in order to return data to the caller. And now, as you can see, so this is an event-based architecture. So what's now happening when you receive such an event? It will go to the AWS Lambda service, and this will then make sure to instantiate a function or a function instance. And it will then provide this data to your function. And as soon as another request or another event happens and comes in, it will reuse this instance. But as soon as you hit, for example, a traffic spike, it needs to make sure that the other events are handled as well. So it needs to create more function instances of your function. So that means you might have a lot of instances for your function, not only one. All right, so these were the basics now, which you might have already known before. So let's quickly hand over, like, how can you actually develop those functions? You have basically two options here. So you can develop them locally on your local system or also directly in the cloud. And for the local development, you have, for example, choices to use the serverless framework or the serverless application model with the SAM CLI or local stack to develop your functions locally and also execute them locally. You can also do the same in the cloud, for example, using the AWS Cloud 9 IDE, which has a pretty nice integration with Lambda functions. But the other alternative is, of course, you develop your functions locally and then run and execute them in the cloud. The only kind of problem is if you run your functions in the cloud, you do not have some debugging options available. So you need to lock your data if you just execute them in the cloud. There's a small exception here. So I found a blog post about someone who's actually debugging some .NET functions. I think you can do that, but I think it's a quite tricky setup and not so really recommended. So what you need to consider here for, what you want to, in order to provide you with a decision, you should consider these three things. So first, if you want to have a real environment, there's no way around to execute a function in the cloud, of course. Because if you do this locally, it's just a lot of simplification. You need to mock services, and this is not like a real environment. Also, the code updates. Local code updates are usually a lot faster because you don't need to upload and update your code in the cloud. But this can also be optimized a bit so that you can update your code a bit faster. And also regarding testing your functions, of course, you always need to write tests. But if you do this like in a good way, that you separate your business logic and the infrastructure glue code, you can also debug or test your business logic locally and then have running some integration tests in the cloud so you can easily spot some errors while developing and testing your functions on your local system. Okay, so now that you know this now, you can actually start coding, right? Well, if you now do this and create hundreds of functions, you might run into a small problem. Because manual managing functions is quite a pain if you have 10, 20, 50, or 100 functions. This can create a lot, and it is a really big overhead to do this. You don't know which code you have deployed where, and you probably lose the overview. So in order to avoid that, I strongly suggest to use something to describe your infrastructure as code. You can use one of the previously mentioned frameworks like the serverless framework or the serverless application model from AWS to describe your infrastructure and also make sure that your code is deployed and up to date, and you can better say what is currently deployed in your stack. If you then combine this now with a CI/CD pipeline, that makes it even better and less error prone. In this context, also a small hint here, if you develop your app for the marketplace, you might never know how fast your customers are actually updating your code. So you could add, for example, something to identify which which version is actually deployed and which version is actually updated at your customer. So as soon as he says update, he's using your new function, but this might take some time, and also depending on which changes you make for your functions or for your app. All right, then let's dive into the best practices. The first best practice is about the function scope. And what do I mean with that? I want to give you an example. So let's try to consider you have different tasks to do in your app. This could be like in our case, you want to receive webhooks, or you want to synchronize content, and then you want to do some further processing. What you can do is you can just put that into one Lambda function and let it run for you, and that's totally fine. It works. But the problem is this can kind of like blow up your function and reduces the scalability of your app. So my advice here is that you should keep it simple and stupid. So you should separate your concerns. And the considerations you have to make here is that you should focus on one thing, what your function should do, and do it very well. This might also then lead to a better reusability in your app, so that you can reuse functions in different contexts. Also, what you have to consider is the performance of a Lambda function itself. So you pay for the execution of your function. You pay for every 100 milliseconds, and if your function runs a lot longer, it costs you money in the end. And talking about performance, let me show you what I actually mean with that. When you use Lambda functions and no instance exists so far, then you have, or AWS and also the other cloud providers need to start your function first. So this is then called the cold start of your function. And it needs, for example, to start up like a Java virtual machine if you're using Java, or initialize some framework, whatever. And this can take some time, and in the end, it costs you money. But afterwards, as soon as the function is, had this cold start, this initial one, your function is warmed up, and usually those response times are quite slower. And if you now can make sure that you can reduce the response times by, for example, reducing also the size of your Lambda function, so to not put everything into one function, but to separate your functions and your concerns, you might be able to reduce this cold start time. Because the bigger your artifact, the slower is the startup time. Yeah, there are ways to reduce that by, for example, keeping your functions warm. But as soon as you hit a spike in your traffic, you still run into this cold start. So warming up functions will never eliminate the chance that you run into a cold start. Speaking about also, no, I didn't say that. So it always depends a bit on which language you use, which programming language. And now, if we're speaking about the different programming language which you can actually use, it's not only like the standard ones like Java or Node.js, Python, whatever. Nowadays, you can use all kind of different languages. So on the last AWS reInvent, they have announced that you can bring your own runtime for your Lambda functions. And this is quite nice. But you also should consider here, if you bring your own runtime function, you also have to maintain this somehow or make sure that it's working correctly. So keep that in mind. I recommend to go with the standard ones because they're well proven, and so you don't need to hassle around with those custom runtimes. And usually the next question which I always get is then, well, can I use my framework X? For example, for Java, it's quite common that Java programmers ask, can I use Spring in my Lambda functions? And well, the simple answer here is definitely no, you shouldn't do that. So one reason is that as I mentioned, you should keep your function size as small as possible. But there's also another reason why you shouldn't do that. And that, like, if you ask yourself, why are you actually using those frameworks, like, for example, Spring for Java developers, you not only use that for some context or for some dependency injection, you also use that for some kind of like security, authentication, logging, database access, whatsoever. But in the cloud context and for your Lambda functions, you usually don't need that because you can buy this as a service. So you can buy authentication, you can buy a good kind of like database support, logging is also provided out of the box. You don't need that, to be honest. And then the next point is, people then tend to, I can reduce my Lambda function, the size, I make it as fast as possible. I am then able to use it as a REST API. And there's also a simple answer, but take this with care. So I would say you shouldn't do it if you're really concerned about response times. So if you have certain policies or SLAs that tell you, oh, you have to respond in, I don't know, 50 or 100 milliseconds, you might probably not reach that with Lambda functions. But of course, I can understand that you want to use it as a REST API, and I think it also makes somehow sense. So if you are not too concerned about your response functions, you might actually use that. So, but keep this in your mind that this cold start exists, and you might never completely eliminate that. There are ways to do this. So you can use, for example, the API gateway, which is kind of like a barrier in front of your Lambda function, which supports you with some authentication helpers and whatsoever, and DDoS protection. But there's also another solution, which is AWS AppSync, which is using the GraphQL framework. So you have the GraphQL capabilities behind this, and with the AWS AppSync, you can directly attach even database tables or Lambda functions, and I think I read this on Twitter yesterday or this weekend that you can also now directly access other HTTP services via in Amazon. But I haven't looked into that, so that's without guarantee. Right, and there's a link to a very good blog article from cloudonaut.io, which you might want to check out, which gives you a really good introduction into AWS AppSync with Lambda and DynamoDB. Okay, next point is about communication. And by communication, I mean the communication between your Lambda functions. There are two ways to do communication between your Lambda functions. Either asynchronous communication, which means you directly call your Lambda function. But so in this case, you will hand over a payload to a function and provide it with some data. But the problem is that this payload can grow quite a lot, and you might reach the limit of the AWS Lambda service that tells you, oh, you have provided too much payload data, I cannot call your function, sorry for that. So what can you do in order to avoid that? The first and probably the most basic and simple approach is you could simply split up this payload and call your function twice. But this has the negative effect that if your function needs to have the whole data at once and cannot work with that if it's separated and maybe even handled by different Lambda instances, this might help you a lot. So there's a second option, what you can do, and this is that you upload your payload to another service, like, for example, Amazon S3, and just provide a key to this certain file in the payload. So this is then enough. But there's also a disadvantage here, of course. You have to first upload your data to the service and then download it again when in the other function. So if you do this quite often, you pay Amazon a nice bill to upload and download your data. But there's also the asynchronous communication. And maybe this is an alternative also for you in order to overcome the previous problem. So instead of calling a function directly, you might want to decouple your communication and instead move this payload to different services. And then you use those services as some kind of like transport layer. So a bit similar to what I said before, but now you have a pretty interesting thing here because for all of those services, you can attach your Lambda function again and register for updates on those services. So as soon as, like in like those services are triggering an event, for example, that a new file is uploaded to S3 or a new data is added to your table, you will be notified and your Lambda function gets invoked. And the cool thing here is that you're not only able to attach one function to it, but actually you can attach multiple functions to them. And that's really nice because if you have, for example, new requirements at a certain point of time, you could just attach a new function to that and you're done with that. So if you want to read or want to use the payload in multiple ways. The next point is about the scalability of your functions. And now you might think in your head, like, why should I talk or why should I think about that? Because these functions are scaled automatically, right? Consider this, for example. If you are working with Jira or Confluence, it's really easy to get 1,000 webhooks at the same time. For example, in Jira, if you make a bulk action of 1,000 issues, Jira will send 1,000 webhooks to your app within, I don't know, a few seconds, 1, 2, 3 seconds. And if you cannot correctly work with that, it's a problem for you. But coming back to your question, this question, yes, my Lambda functions are scaled automatically, you're right. But the problem is that the other services which you are using, they might not be scaled automatically, and then you have a problem. Let me give you an example here. So you have your Lambda service, and a request or an event comes in, and then it will scale up your functions, and those functions are accessing a certain service. And let's say it starts 500 instances of your function. You have 500 functions which are accessing the same service. And as you can imagine, if you do that too often to access the service might simply die. And that's not what you want to have. So the question is, how can we actually prevent that? And the solution is that you kind of like buffer at least the webhooks or those requests which are coming from Jira. And you can do this like this. So you have a function which is receiving webhook data, and then it's pushing the webhook data to some kind of queue. In this case, I'm using Kinesis because it's a quite performance service. And then behind Kinesis, you attach another Lambda function, which is then reading from the stream. So as I told you before in the previous section, you should have, or if you use some asynchronous communication, you will benefit here again. And also if you separate your functions, doing only one certain thing and do it very well. The next best practice is about the execution management of your functions. So you might know that your functions have a certain limit for how long they can run your code. This is about 5 minutes. Okay, actually it's about 15 minutes. So they changed it last year, that you have more time to execute your functions. And now you might also think again like, well, 50 minutes are a lot for me. I don't need this amount of minutes. And my question back to you is, really? How can you be sure that this is really enough for you? And I want to give you a short example here how this, or why this could be a problem. So in our case, we want to, like for our Backbone sync app, we want to synchronize, for example, 1,000 issues. If someone creates a new synchronization between two projects, and those projects have already some issues. And let's assume that it takes a certain amount of time to do certain things, like retrieving the data, processing it, and then update the data again in the other Jira instance. So in total, this takes 1 second per issue. And if you calculate this, then you have about 60 minutes to synchronize 1,000 issues. And if you do this now in one Lambda function, well, you have easily reached the limit. So you need to think about how you first process them and be like, how do you execute everything? Of course, you can optimize here a bit with some more parallelization within your Lambda function, but there are certain limits which you will always reach. So what can you do in order to kind of circumvent those 15 minutes time limit? One thing is what you can do is you could use recursion. And this is by calling a function again, or yeah, you call yourself again. And this could look like this. So you have your function and you're doing certain stuff. And if you like processing certain issues, you might check how much time is actually left for my function. And if I don't have enough time left anymore, I just store my state and call myself again. But there are two problems arising here. So the first problem is you cannot be sure that you get the same instance again. So even if you store your state somewhere in your function, you might never be sure that the same function is called again. So that means you need to store your state somewhere else in another service, like, for example, an S3 bucket. But then if you do this and store your data in another service, the second problem arises. And this is that you can never be sure if this threshold is high enough. Because if you then store your state and this request to store your state takes, I don't know, 1.5 seconds, you have reached this limit. So really take care with that if you use such an approach by calling yourself again. The other option is you can outsource this to, for example, an EC2 instance. This is possible by, I don't know, having some Docker container and then just say, okay, just run this now and run my task. I don't care if it takes an hour or not. Just do it, because the EC2 instance, I mean, it will just live. But since we are in a serverless approach, you might not want to do this. So serverless by managing servers, I don't want to do it. Another option is then to use AWS step functions. And AWS step functions is quite a nice way to manage the execution workflow and work around this time limit. And here's just a simple example how the step functions service works or can look like. So what you define is you define some kind of state machine, which then, in this case, it's just waiting for a timestamp, and then after that, it sends an SNS message. And you define this by providing a JSON document, and then kind of like these states are connected to what you write into the document. And this is quite cool because you can provide some Lambda functions as your state. So as soon as the state is reached, those step function service will call your function and then execute it. And you have some other things, like they have some predefined states, like, for example, this one here with a wait state, so that you wait a certain amount of seconds. You can even do some retries, so if your function fails, you can make a retry, or there's also an error option, if I recall that correctly. So if the function still has some problems, you might send out a notification to yourself, hey, please take a look at this function, it's not executing. The next best practice is some kind of like collection of limits. What else is here in Lambda, what you need to consider. And so one special limit is here about the memory allocation. So you might know that you have up to 3 GB for your memory allocation available. But if you choose the memory, you should be aware that the memory allocation and the CPU power correlate. But not only those, also the network bandwidth and the I/O disk throughput, they also correlate to each other. So the more memory you allocate, the other things also increase. Regarding the artifact size of your Lambda functions, you also have a limit there, so it's about 50 megabytes. And this is now especially interesting for Java developers because you need to improve your dependency management. If you just include library after library after library because you don't want to write an equals function for your string utils, for example, and you just include the string utils from the comments, and you do this for every other library, you might end up reaching this 50 megabytes limit. And this is not so nice. Furthermore, you have only a temporary storage of 512 megabytes, so of local storage. And here you have to take care about that. And everything else which is above this, you need to store it somewhere else. Or if you say, okay, I can't split my data up so that I can process this with my Lambda function, maybe Lambda is not, or serverless in general, is not the right thing for you. And then there's the last best practice. It's about the maintenance. I think Lambda functions are also pretty cool to maintain your stack and your app in general. So you can, for example, clean up some data with your Lambda functions, or even make sure that your that your data is still up to date. For example, by checking every night if you have kind of like missed some webhooks, because I know webhooks are not 100% reliable. So if you have some kind of mechanism to know if you have missed the webhook, you could just create a Lambda function and check that each night, for example, and then send out some notification or prepare the data to reprocess it. Or you could do some log analyzing, I don't know, for certain keywords, for example, and send out a trigger to you or put the log files into another service. And you can also do some monitoring for your own services by providing some health checks, for example. I have some examples here for you. So you could also shut down some resources at night. So we do this in our developer stack. We're not 100% serverless in our app, so we also use some EC2 stuff. So what we do then in our developer stacks is that we just shut down the EC2 instances at night, so we can reduce some costs. Or we have some function which is kind of like cleaning up some Lambda groups. So if you change your Lambda functions a lot, you might have some Lambda groups which are, I mean, if they have some automatic identifier, and if you rebuild your stack, this might get a bit problematic. So we have a function to clean this up as well. Or to analyze your logs for the keywords, as I have mentioned before. And now a quick look ahead what I have now I have talked about quite a few things in my talk, but I haven't covered everything, of course. So here are a few links what you should consider to have a look at again. For example, one important case is about security of your Lambda functions. So you can secure your functions, for example, by giving it least permissions so that it cannot do everything in your stack. And there's a really good blog post article about it, what you can do in order to prevent that, I don't know, your functions are doing some weird stuff and maybe destroying your app. There's another thing, it's about legacy code. So what happens if you have a legacy application like we had with Backbone? And there's a really, really good series of blog posts from Jan Chui. He's a pretty well-known guy in the serverless context. He has done a pretty similar thing when what we did. So he had an app, and he just moved everything to serverless functions. In the end, he had a really like a jungle of serverless functions. It's really interesting if you see the graphics from him where he had his architecture documented. So if you want to read something about that, how you can manage this, for example, if you're coming now from server and want to do something in the cloud with Lambda functions, I can highly recommend to read this blog post. And there's also something about caching data in your Lambda functions. Because as I have previously said, if you have, I don't know, 500 instances of your Lambda functions and they are accessing the same service and might even kill your service, or you have some API rate limits or whatsoever, you might want to consider that you cache your data. And actually, I have written a blog post about it, what different options you have in order to cache data in your Lambda function. So you might want to check this out as well. In general now, I can tell you that I think serverless functions and additional services are quite a good mix for your app. So it's pretty cool what you can do with that. And I think one really nice advantage here if you use those serverless functions is that if you use them, you are able to easily attach, for example, to attach new functions to your app. So if you have new requirements coming up, you just say, actually, I don't need to replace any other function. I just attach a new function to my data and do something else. For example, in this case here regarding some analytics, you just say, I attach a function to my Dynamo table, and it gets notified as soon as a new entry is made into my table. And I just kind of like wrap this data, and put it to an analytics service, for example, from AWS. And so you can easily extend your app, which is really nice. So to recap the key takeaways, try to focus in your app, in your function, that you only do one thing and do this really good. Take care about the scalability of your app, or of your functions, because if you, as mentioned, if you don't take care of that, you might kill other services which are not as scalable as yours if you use serverless functions. And also be flexible. So you can do that if you use serverless functions quite easily. Right, and that's it. So if you follow my best practices, you'll be able your app, your business, and beyond. Thanks a lot.
One moment. All right. Thank you so much, Sebastian. That was an awesome talk. Does anyone have any questions? I want to start with one from myself.
Okay.
The keeping them warm. How often are you? First of all, do you just cron these things that are just kind of running themselves every 5 minutes or less? How do you keep them warm?
Yeah, right. So you can keep them warm by, for example, every minute you just make a small request or call your function, and then in your code you have to take care about those warm-up requests. So you could, for example, tag them somehow with a keyword and say, okay, if the payload contains a certain keyword, I just skip the execution and just exit again. And then for everything else, you just do your usual code, and by that you can keep your functions warm. Mm-hmm. Yeah, that's okay, cool. The basic way.
Thanks. Anyone have any questions? All right.
Is it the best practice to keep it warm?
Well, I think...
Is it a best practices to keep it warm?
Well, I always say if you have to keep your functions warm, you might also consider to set up a normal EC2 instance. Because if there's really a need to keep them warm because you need like a fast response time, or you want to have something running all the time, then you can also use a normal, I don't know, Docker container and just let it run all the time. So I think it's not a best practice. Maybe other people are saying it differently. But I also know from people like from other app vendors, they are using serverless functions, and they nowadays have so many customers that actually their customers are keeping the functions warm automatically. So if you reach this point, you don't have to keep them warm by yourself.
Quick question, as you move to serverless, how do you address, obviously, you don't have any more servers to manage, but there's some complexity on, there's more routes to go through, and how do you monitor and debug when problems go wrong, given the ephemeral nature, especially at the function level? What mindset had to change as you kind of did that migration? If you could just briefly talk about that, and maybe give us an example of a lesson learned.
Just regarding monitoring? Or?
Yeah, monitoring, and if something doesn't go right, how do you go back and figure out what happened and kind of,
So what worked pretty well for us is we have some like monitoring available if our functions are, if they fail. So we get a notification to the developers. So we have set up an SNS topic, and everyone can register from our team to that. And as soon as something fails, we just send a message to that by recognizing it. And so we get notified, you should look into that. But to be honest, there's not so much always going on that it fails, but until now. So I don't hope that it changes. But yeah, so that was actually a pretty good lesson, and you then have to adapt to it. So as soon as you recognize it, that messages are coming again and again, you need to adapt your architecture. And yeah, for example, one thing what we have changed last year as well is we have used DynamoDB tables, and they had this. You can define the capacity of your read and writes, and they have changed it now that you can kind of like use some dynamic capacity usage plans, whatever you want to call it. So we have changed that. So we went to this dynamic one because previously we always ran into some capacity problems. For example, like if a webhooks arrives, or if thousands of webhooks arrive, and you have like just a too small capacity for your tables, they just fail automatically because this auto-scaling from DynamoDB is not so fast for your Lambda functions. At least that was our experience. I think there are ways to optimize this auto-scaling, but we were quite happy as soon as they announced that this automatic scalability applies. Yeah.
And just to be clear, on your slide where you had Kinesis as kind of like the queue, That's an AWS service, correct?
Sorry, I didn't understand.
The Kinesis part on your diagram, you had your Lambda function, then Kinesis, and then the Lambda function picking up the data from Kinesis.
Yeah.
That's another AWS service, right?
Right, yeah. And this is actually, from my point of view, a really good tip that you should buffer your webhooks. Yeah, it will protect you, your own infrastructure, and also the other services, what you're calling. Also now, if you make calls to Jira, for example, again, you also the infrastructure for Jira.
Any other questions for Sebastian? Awesome. Thank you so much, Sebastian. It was a great
Thanks a lot.
Yeah.